Alright, welcome back to another exciting question in trigonometric identities. Now this question says we should prove that square root of 1 plus sine theta divided by 1 minus sine theta plus square root of 1 minus sine theta divided by 1 plus sine theta is equals to 2 sec theta, right? Okay, so let's say solution. Now I want to use the left hand side. Let me prove that this complex left hand side can be this simplified right hand side, right? Okay, so if that's that, let me bring it here. We have square root of 1 plus sine theta all over 1 minus sine theta plus square root of 1 minus sine theta all over 1 plus sine theta. Now this can be broken, right? I can break this one, can break the square root, let everybody be on its own. All over square root of 1 minus sine theta, then plus square root of 1 minus sine theta all over square root of 1 plus sine theta. Let's see them as entities, right? That stands on their own. Okay, so if this is correct, then I can take this as my LCM. So if I take that as my LCM, I'll have square root of 1 minus sine theta and then 1 plus sine theta is 1 to square root, right? Then let's solve square roots now. If the whole of this is brought to be dividing this, so it will cancel its type, only this will be left. So this times the numerator will now give you square root of 1 plus sine theta times another square root of 1 plus sine theta, right? Okay, then plus. Now let's take this denominator and we come here. Then this denominator divided by this value, it will take care of itself. Then this will be left, so we'll multiply by this. So they are also the same type, right? So 1 minus sine theta times square root of 1 minus sine theta. Alright, so that's what we're going to have. So let's multiply these two now. This 2 is like saying a square times a square. The square root of a times square root of a, right? So this is going to give you square root of a square. This will cancel this and you're left with what? A. Is that okay? So let's multiply this now. This times this, the square that it will create will remove the square root. Or let's just show the step once and for all. So this is going to be 1 plus sine theta all square, then plus square root of 1 minus sine theta all square, all over. Let's keep the denominator first. We'll handle that one later. Alright, so now let's cancel to this square will cancel this square will cancel this. So you are left with 1 plus sine theta, right? Then plus 1 minus sine theta. That will be our numerator. Then all over, let's deal with the denominator now. Now looking at the denominator, if we are multiplying this, we all know that this square root can take precedence and then this value can be 1 minus sine theta into 1 plus sine theta, right? Okay, so let's write the numerator first. 1 plus sine theta plus 1 minus sine theta all over. Now we should recall that whenever we have something as 1 minus a into 1 plus a. The answer is going to give us 1 minus a all squared, right? Good. So if that's that, let's apply it here. So we'll have the denominator to become 1 minus sine theta all square with the square root, right? So here we're going to be, let's expand this now. This is going to give us 1 plus sine theta. Expanding this, we have plus 1. Then plus times minus give you minus, then sine theta all over. This square will cancel this square root, so you are left with 1 minus sine theta. And this is going to give us 1 plus 1 is 2. Sine theta minus sine theta is 0 all over 1 minus sine theta, right? Okay, so now let's also recall that, so we're going to be having, this is going to give us 2 over cos theta, because 1 minus sine theta is also cos theta, right? Okay, so we're going to be having 2 times 1 over cos theta. And inverse of cos theta is sec theta, right? So we have sec theta. This will conclude our derivation for this question. But let's not forget that in this position here, we can still leave this value and substitute it with cos theta, right? So 1 minus sine theta will be same thing as 1 minus sine square theta, since it is squared here and the square root is here. So we can then substitute this with what? Cos square theta. And then this square can cancel this, so we still have what? Cos theta, right? That's why we have cos theta here. So this operation is still correct. And then we'll have this, and then we are here. So I just say, let me break it down, because some people will not know why I said 1 minus sine theta is equals to what? Cos theta. Is that okay? All right. Thank you for following from start to finish. I will see you in the next video. Bye for now.